Hello, everyone. Welcome to the Math Magician's Den. This is the Herm Dog, and we are going to talk about maximums and minimums, or in mathematics, as we like to call, extrema. What are maximums and minimums? First of all, the minimum and maximum of a function on an interval are the extreme values, or extrema. Singular form of extrema is extrema. And this is for any function on an interval I. So if we take some function and we're drawing this function and we pick a specific interval, okay? And when I say we pick a specific interval, we could say from here to here. What is the maximum on that entire interval? Well, the maximum on this entire interval would be this point right here because it is the highest point on the entire interval. This value at C, which we call f of C, is greater than or equal to any other f of x on that particular interval. Okay? Same thing with a minimum. If we're going to do a minimum on this entire function, the minimum value has to be the lowest point. For us here, it would be this point at the end. This f of c would be the lowest point on the entire interval. Now, when we talk about maximums and minimums, okay, you'll notice a maximum or a minimum can be at an endpoint. A maximum or a minimum could be at a spot where the graph goes up and then down, or it goes down and then up. Now, why is this point right here not a maximum? Well, when we say maximum, it means the highest point. We're going to refer to that as the absolute maximum. Okay, so usually when teachers ask for a maximum, usually when math books ask for a maximum value, they want an absolute maximum. So when you guys are looking at this graph, this point right here is called the absolute maximum. Sometimes this is called a global maximum. It's the highest point on the entire graph. This point I have over here in the green, this one is an absolute minimum. It is the lowest point on the entire graph. Sometimes, again, it's called a global minimum. Now, like I said, when we're looking at other points here, this point right here is not an absolute maximum. We'll discuss that in a minute. Okay? This point right here is not an absolute minimum. Okay? Those 2 points are called relative maximums or relative minimums. Okay, so what's the difference? This point right here is actually a relative maximum as well. A relative maximum basically says if there is an open interval containing C on which f of C is a maximum, then f of C is called the relative maximum of f. Okay? Or we can say local maximum. When we say relative max or min, it's the same as saying local max or min. Okay? Now, what's the difference when we talk about relative maxes and mins or local maxes and mins? First of all, an absolute max or an absolute min. In fact, let's put the word absolute here. An absolute max or an absolute min, all you have to know, it has to be the highest point on the graph or it has to be the lowest point on the graph. It can be an endpoint. Okay? Absolute maxes and mins, like right here, can be the endpoint of an interval. Or an absolute max or min could occur at a relative max or min, like it did right here. Now, when we talk about a relative maximum, you've got to see it go up and then back down. That's a relative or a local maximum. If you're talking about a relative minimum, you have to see the graph go down and up. So this right here at the end point, right here where I'm darkening it in this arrow, that is an absolute minimum, but it cannot be a local or a relative minimum. This point right here, in fact, let's call this point A. A is a relative maximum, but not an absolute maximum. Point B is a local or a relative minimum because it goes down and up. Okay? but it's not an absolute minimum because it's not the lowest point on the graph. Point C over here is not only an absolute maximum because it's the highest point on the graph, but it is also a relative maximum because the graph goes up and down. Now, as we move down the page here, okay, let's try a couple problems here in identifying maximums and minimums. So I want you guys to think about, and you can even pause the video to see if you could answer all of these. I want you to decide whether each point is an absolute maximum or absolute minimum, a relative maximum or a relative minimum, or maybe it's neither one. Well, point A. You should notice on point A, it's an endpoint. So it cannot be a relative max or min. In fact, it looks like A is the lowest point on the entire graph. Point A is an absolute minimum. Well, what about point B? Point B looks like it's the highest point on the entire graph, so it is an absolute maximum. But here's the thing. It is not only an absolute maximum, that graph right there in that locality, relative to that area, it's the highest point. This is a relative maximum as well. Yes, it can be both. Now, point C doesn't, in that area, it's not the highest point, it's not the lowest point. This is neither a max or a min. In fact, you guys will figure out later on, point C, it's called an inflection point. And I'll discuss that in another video. Point D, it looks to me like point D is not the lowest point on the graph, but it definitely goes down and up. So this is a relative minimum. It's not an absolute minimum because it's not the lowest point on the graph, but it is a spot where the graph goes down and up. Point F, funny thing, I don't have a point E on this graph because when I draw these graphs on the program I was using, if I put E, it would put 2.718. It would give the base of the natural logarithm. But point F here, doesn't matter if it's smooth or if it's a cusp like this. Point F, this is a relative maximum. The graph went up and then it went down. At G, it went down and then up. This is a relative minimum. But it is not an absolute minimum because it's not the highest or lowest point on the graph. Now, when we look at point H, I hope you notice real closely there, point H, there's no point there. So it can't be a max or a min because there's no point. And point J, it's an endpoint. So it cannot be a relative max or a relative min. It is not the highest point on the graph. It is not the lowest point on the graph. So this is neither one again. It's neither an absolute max or an absolute min. And it cannot be a relative max or a relative min. Now this graph right here, let's do some listings here. First thing I'm going to ask for, are there any absolute maximums? And yes, there can be more than one absolute maximum. If they're all the same y values, you could have more than one absolute maximum. It looks to me like the highest point on the entire graph is right there at R. Is there an absolute minimum? Is there a point that's the lowest point on the graph? It looks to me like it's right here. So U is an absolute minimum. Do we have any, and I'm going to use the word local this time like they are here. Local just means relative. So if I say local maximum, where do you see the graph go up and down? Well, I see the graph go up and down right there at R. I see the same thing happen at T. Those are local maximums. What about local minimums? A local minimum would be right here at S because I see the graph go down and then up. The same thing at U. The graph goes down and then up. U is a local minimum. Now the points at A and B. This is not the highest or lowest point, so it cannot be an absolute max or min. it can't be relative because you don't see it go down and up. And some of you might say, well, it might go up to the left of that. No, we don't know. So we don't say so. Same thing here at B. The graph does not go up and then down. It doesn't go down and then up. It's not the highest or lowest point on the entire graph, so that's neither one as well. Everyone, I hope this helps with maxes and mins, relative maxes and mins, local maxes and mins, absolute maxes and mins. If you like this video, please hit like and subscribe. I would really appreciate that. I'll be posting more videos in the future.